Good day everyone. Today, I will represent the course project in Data Communication Networking 1, entitled Networking Fundamentals. Basics: network collection of nodes and links that cooperate for communication. Nodes: computer systems, internal routers, bridges, switches, terminals, and workstation. Links: connection for transmitting data. Protocol: standard for formatting and interpreting data, controls information. Network nodes and links. Nodes have addresses. Links have bandwidths and latencies. Wires aren't perfect. Attenuation resistance, degrade quality for signals. Delay, speed of lights 2/3, speed of lights 8 ms, RTT coast to coast, 8 minutes to the sun. Noise, microwave and sax. Nodes aren't perfect either, unreliability is pervasive. Getting data across imperfect wires split up big files into small pieces. The pieces are called packets. Each packet is 1,500 bytes, is sent separately. Packets can be corrupted, noise bugs. Packets can be dropped, corrupted, overload nodes. Packet can be reordered. Allows packet from different flows to be multiplexed along the same links. Layers: each abstract the services of various lower layers, providing a uniform interface to high layer. Each layer needs to know how to interpret a packet payloads, e.g. protocols numbers, how to use the service of lower layer. OIS labels nodes: application nodes B. Nodes A, presentation, node B, presentation. Transport network to node B. Data link to node B. Node E, physical to node B. Network. Layers: OIS reference reality packets formats. Application, presentation, session, transport, network, data links. Physical: reality is HTTP, TCP, network, IP, data links, Ethernet. Physical twisted pair. Packet format: app data, IP payload, Ethernet payload. The Internet Protocol's IP connection disparate network. Single hierarchical address space, single network header. Assume data links is unreliable, provides unreliable. Lost ABDE, duplication is ABBCDE, corruption is AQCDE, reordering ACDBE. IP address: 32 bits long, split into 4 octets, for example 128.95.2.24. Hierarchical: first byte describe with network, last bits describe which host on the network. UW subnet include 128.95 and 140.142. OWCSE subnet includes 128.95.2 and 128.95.4 and 128.95.219. Packet forwarding. Buffering incoming packets. Decide which output link, buffer outgoing packet, send packet. Routing. How do nodes determine which output link to use to reach a destination? Distributed algorithm for converting on shortest path 3. Nodes exchange reachability information. I can get to 128.925.2 times in 3 hops. Shortened path 3. X is the cost to get to 6. The metric cost per link. Here is one simple algorithm. 6 broadcasts. I'm alive to neighbors. Neighbors send. I can get to 6 in 1 hop, etc. Route aggregation. What hierarchical addressing is good for? OW routers can advertise 128.95.x instead of 128.95.2.x and 128.95.3 and x blah blah blah. Other routers don't need forwarding tables and interest for each host and network. Routing reality. Routing in the internet connects autonomous system AT&T, Sprint, UUNet, and BBN. Shorten paths sort for money talks. Actually, horrible means nobody really knows what's going on. Get high dollars job if you are a network engineer that messes with this stuff. TCP services model provides reliability, ordering or unreliable, unordered IP. Byte stream oriented. When you send a data using TCP, you think about bytes, not about packets. TCP port connections are identified by the tuple IP source address, IP destination address, TCP source port, TCP destination port. Allowed multiple connection, multiple application protocols between the same machines. Well-known parts for some application: web, AT, telnet, 223, mail, 225, DNS, 0.53. TCP/S sliding windows. Simple reliability. Send one packet, wait for acknowledgement, then send the next. Better performance. Keep several acknowledged packets in the network a window. Sliding window example. Send 1, send 2, and send 3. Send 4, send 5, send 6, send 7, send 8, send 9. Then Act 1 to Act 2, Act 3, Act 4, Act 5, Act 6, Act 7, and Act 8. Window size is equals to 3. Can send up to 3 packets into networks at a time. Each packet has a sequence number for ordering. TCP/S congestion control. How big should a window be? Performance is limited by window size, route trip time, performance for bottlenecks, link modem. If window is too small, performance is waste. If window is too big, may overflow network buffering, causing packet lost. Step for a web access. Name lookup. Client to local DNS server. Local DNS may return a cache binding or look up the name for itself. TCP connection setup. client to remote IP port 80. Send HTTP requests, get index, and point HTML. Receive HTTP response, blah blah blah, maybe several packets. TCP connection teardown. HTTP 1.1 incremental improvements. Persisting connections allow multiple requests over the same connection. Web transfer are often small. Avoid connection setup and teardown overhead. TCP is better the longer you get it. It learns how fast to send to get best performance without overflowing buffers. For networking types and topologies, computers' network topology is the way various components of a network links, nodes, links, peripherals, etc. are arranged. Network to topologies defines the layout, virtual shape, and structures of network, not only physical but also logical. The way in which different systems and nodes are connected and communicate with each other is determined by topology of the network. Topology can be physical or logical. Physical topology is the basic layout of nodes, workstations, and cables in the network. Logical topology is the way information flow between different components. Type of physical network topology: bus topology, star topology, ring topology, mesh topology, tree topology, hybrid topology. Bus topology is, in the bus topology, the computers are connected through a common communication media. Special type of central wires is used and communication media. The central wires is called bus. The computer are attached through the bus, and ends of the bus are closed with a terminator. The terminators are used to absorb signals. Next is advanced of bus topology. Easy to install and configure, expensive, easily extended. Disadvantage of bus topology: performance decrease, weak signal, difficult troubleshooting. Star topology. The star topology used to separate cable for each workstation and show in the cable connection the workstation to a central device, typically a hub. The configuration provides a more reliable network that easy expanded. With stars, there's no central point for failures in the cable. If there is a problem with a cable, only the station connection to that cable is infected. That add more workstations, simply connect another hub. Advantage of star topology: easily expanded and modified, easy to troubleshoot, multiple cable types supported by hub. Disadvantage of star topology: if hub failures, the entire network will fail. Required more cables, may require advanced to rebroadcast signals across network. Ring topology: every computer is connected to the next computer. The ring, and each transmit that received from the previous computer. The messages flow around the R in one direction. Some ring networks do ring tokens, passing a short missing called tokens. Memory R is passed around and ring until a computer wishes to send information to other computers. The computers modifies token adds an electronic address and data sent in around the next computer until either that electronic address matches the address of computer, or the token returns to our original. The received computer returns a messages. The sender indicate that message has been received. Advantage: it provides an orderly network in which every device has access to the token and can transmit. It performs well under a heavy load. Disadvantage: failures of one computer can affect the whole network, difficult to troubleshoot. Change mode with adding or removing a device affects the entire network. Missed topology. A missed network or missed topology use separate cable to connect each device to every other device. On the sending message, check the cable connected into two devices. A message is sent directly from a sender to receive because each one has individual and separate connection. Advantage: enhanced for error tolerance provided by redundant links, easy to troubleshoot. Disadvantage: difficult to install and maintain, expensive. 3. Topology. The types of network topology is which a central root nodes the top level of the hierarchy and connected to the one more other nodes that are one level lower in the hierarchy, i.e. the second level with a point-to-point like between each of the second level nodes and the top level central root nodes, while each of the second level nodes that are connected to the top level. Central root node will also have one or more other nodes that are one level lower in their hierarchy, i.e. the third level connected to it, also with point-to-point link, the top level central root nodes being the only nodes that has no other nodes above it in the hierarchy. The hierarchy of the three symmetrical, each nodes in the network having a specific fixed number of nodes connected to it, and the next lower level in the hierarchy, the number being referred to as the branches actors of the hierarchical tree. Advantages: it is scalable. Secondary nodes allow more devices to be connected to a central nodes. Point-to-point connection of devices having different levels of the network make it more manageable, hence easy fault identification and isolation. Disadvantage: maintenance of the network may be an issue when the network spans a great area, since it is a variation of bus topology. If the backbone fails, the entire network is crippled. Hypertopology. Hybrid network use a combination of any network or more topologies such a way that the resulting network does not exhibit one of the standard topology, bus, stars, ring, etc. For example, a tree network connected to a tree network is still a tree network topology. Hybrid topology is always produced when two different basic network topology are connected. To common examples for hybrid networks are star ring network A. Chapter 2: Network Models. Layer tasks. The OIS model. Layer is in OIS model TCP/IP protocol suites addressing. Layered model sending letter. See pictures for the examples of sending to receive. Example is letter is writing put in envelope from the sender and dropped in mailbox. The letter is carried from the mailbox to a post office. The letter is delivered to carrier by the post office, then the parcel is carried from the source to the destination. Lower layer is the letter is delivered from the carrier to the post office. The letter is carried from the post office to the mailbox. The letter is picked up, removed from the envelope, and read by the receiver. OIS model. Established in 1947, the International Standards Organization, ISO, is a multinational body dedicated to the worldwide agreement on international standards, an ISO standard that cover all aspects of network communication in open system interconnections, OSI model. It was first introduced in the last 1970. ISO is the organization, OSI is the model. OSI model. ISO is the organization, OSI is the model. See the samples in the pictures. Interaction between layers in OSI models, also layers and interface. You can see the examples of layers and interface in the pictures. Exchange using the OSI models. Encapsulations with the headers and possible trailer. See the example in the pictures. Physical layer. The physical layer is responsible for movements of individual bits from the hop node to the next. Mechanical and electrical specification, the procedure and function. Physical layer duties. Physical characteristic of interfaces and media. Representation of bits, data rear, synchronization of bits, line configuration, physical topology, transmission. Data link layer. The data link layer is responsible for moving transframe from one hop node to the next. Transport the physical layer to the reliable error-free link. Data link layer duties: framing, physical addressing, flow control, error control, access control. Example of hop-to-hop delivery. See in the pictures. Network layer. The network layer is responsible for delivery of packets from the source host to the destination. Network layer duties: logical addressing and routing. Transport layer. The transport layer is responsible for delivery of messages from the pieces to another. Transport layer duties: service point, port, addressing, segmentation and reassembly, connection control, flow control, error control. Reliable process-to-process delivery of messages. See in the pictures the example. Reliable process-to-process delivery of messages. Session layer. Session layer is responsible for dialogue control and synchronization. Presentation layer. Presentation layer is responsible for translation, comprehension, and inscription. Application layer. Application layer is responsible for providing services to the use. Application layer. Application layer services: network virtual terminal, mail services, file transfer, access and management directory services. Summary of the layers: to translate, encrypt, and compress data, to provide reliable process-to-process messages delivery and error recovery, to organize bits into frame to provide hope-to-hope delivery, to allow access to the network resource, to establish, manage, and terminate session, to move packets from source to destination to provide interworking, to transmit bits over the medium to provide mechanical and electrical specification. Example of TCP/IP and OIS model. TCP/IP protocol suits host to network. Physical and data link layer, no specific protocols. Network layer, IP Internet protocols. ERP address resolution protocols. wrap reverse, ERP, ICMP Internet Control Messages protocols. AGMO Internet Group Message protocols. Transport layer. TCP transmission control protocols. UDP user diagram protocols. SCTP stream control transmission protocols. Application layer, combined session, presentation, and application layer. Addressing, 4 levels of address in TCP IP protocols: physical, link, logical, IP network, port, and specific addresses. Example of physical address: a node with physical address 10 sends and framed to the nodes by physical address 87. The two nodes are connected by a link, bus topology, LAN. As the figures show, the computers with physical address 10 is the sender and the computers with physical address 87 is the receiver. Example of logical IP address. And the physical addresses will change from hope to hope, but the logical address usually remain the same. Port address. The physical address change from the hope to hope, but the logical and port address usually remain the same. See example in the pictures. Specific address. Some applications have user-friendly address that are designed for the specific address. Example, email address. Define the recipient of an email. Example, URL, universal resource locator, used to find documents on www.